couple of quick intermediate value theorem problems. Actually, first, you know what? Let's first go way up here and do this problem. What about a value d such that cosine of d equals 1 over the square root of pi? Okay. Well, what we can say is something similar to what we did before. We know, well, one sec, we know cosine is continuous everywhere. Also, we know cosine of 0 equals 1, and cosine of pi over 2 equals 0. So by the IVT, there's some d in the interval 0 to pi over 2, such that cosine of d equals exactly 1 over the square root of pi, right? Because 1 over the square root of pi is between 0 and 1. Okay, so that's it. That's all there is to say. All right, now let's scoot down to these problems. Right, same sort of thing. In this case, let's let f of x be defined by negative x cubed plus 17. So f is continuous everywhere. Right, it's just continuous everywhere. It's always important to say that. You have to say that. Also, f of, let's say 0 is greater than 0. And, get the comma there. And f of, I don't know, 3 is less than 0. So by the intermediate value theorem, there's some c in the interval 0 to 3. I don't say with, we've always said such that. We'll just keep writing that. Such that f of c equals 0. Okay. So negative x cubed plus 17 equals 0 has a real root. Now, actually, in this case, I suppose if we think about it, we could identify that real root. All right, we could say, actually, the real root is the cube root of 17. So actually, we didn't even need the IVT for that one. But still, that's how you would do it. All right, let's look at this one. Here we really do need the IVT, okay? As before, let f of x be defined by 5x squared plus sine squared of x. So f is continuous everywhere. Also, we know that f of 0 equals 0, which is less than 14. But we also know that f of, I don't know, 5 is greater than 14. So by the IVT, remember, it doesn't matter exactly what the value is. We just need to be bigger than 14. And so by the intermediate value theorem, there's some c in the interval from 0 to 5 such that f of c equals exactly 14. So, well, no, I guess we're done with that. Right, because f of c equals exactly that guy. So, all right. So we're done.